A rectangular concrete beam of cross section 150 mm wide and 300 mm deep is simply supported over a span of 6 meter. So section they had given 150 by 300 and the span of 6 meter they had given. It is pre-stressed by means of symmetric parabolic cable at a distance 120 mm from the bottom at the support section, and also at a distance of 60 mm from the bottom fibers at midspan section. So at support section 120 mm, at midspan it is 60 mm from the bottom. Okay, and initial pre-stress in the cable is 300 kilonewton. P value they are given. So determine the maximum deflection of the beam at a transfer condition they had given. So it is a due to pre-stress and due to dead load we need to calculate, and whatever the deflection you'll get, maximum deflection, for that the second one is central concentrated force to be applied to nullify the above deflection. So to nullify is nothing but it should be equals to 0. So deflection due to the live load, it should be equals to 0. That live load is a point load that we have shown here, right? Next, so we'll take the cross section 150 mm wide and 300 mm deep, 150 mm wide and 300 mm deep. So we can calculate the neutral axis, that is d by 2, that is 300 divided by 2, that is equals to 150 mm. Right? Next, so here in this figure we have drawn the position of the parabolic cable 120 mm at the support and 60 mm at the midspan from the soffit. Soffit is nothing but from the bottom. So 6 meter span they had given, total span, and the EC value and the P value they had given, right? So E1 will take it as the distance from the neutral axis to the first starting of the cable at the support. So E2 will take the remaining distance that we have shown in the figure, right? Next, in the next part, so deflection due to dead load we need to find out. For that we'll take the WG is equals to 0.15 into 3, that is the section of the beam 150 by 300 into 25 is the density of the concrete. Okay, so 1.125 we got, that is an UDL load. So it's an UDL. So we can calculate the deflection due to dead load with a UDL force, that is 5 by 384 into W L to the power of 4 EC into IXX. So IXX we can calculate by using BD cube divided by 12 that we have calculated mm to the power of 4, right? So after calculating IXX we can substitute the values. So 5 into W is 1.125, that is dead load we have calculated, into 6,000, 6 meter span they had given. So in the millimeters, 6,000 millimeters, divided by 384 into EC they had given here, the EC value, and IXX is calculated value. Okay, if you'll substitute this, so we'll get the deflection as 1.48, that is the downward deflection. Okay, so next we will calculate the deflection due to pre-stress. So deflection due to pre-stress, for that eccentricity at the support, E1 we will calculate first. That is, for example, the beam is like this, the neutral axis, and the cable will be parabolic like this. So one second. Okay, so it is 120 mm from the bottom. So remaining distance is 150 minus 120, that is 30 mm we got as a E1, and E2 is the distance what we have calculated here. E2 is the distance from 120 to 60. That is E2 we can calculate 120 minus 60. So why we are calculating like this E1 E2? So because we need the distance, the total distance is E1 plus E2. The total parabolic portion we have to calculate. Here the total parabolic portion will be this one. So we are considering this much portion up to neutral axis. That is, both the cables are below the neutral axis. That's why this is also negative sign and this is also negative sign. That you have to remember. If it is below the neutral axis, the negative deflection or the moment we will get. Okay. So next we can consider the bottom which is below the neutral axis. One rectangular portion is there, so that we can consider. And one more is a parabolic variation with considering E1 plus E2. So E1 plus E2, if we will multiply that, I got the answers. P into E1, I got the answer as 9.9 into 10 to the power of 6. So that is the moment, right? So next, deflection due to pre-stress is equals to area into x bar divided by EC into IXX. So that is the default formula. So 1 minus, because both the things are minus, that's why I'll take minus divided by EC into IXX. I'll keep it outside. And next, I can calculate the remaining things. What is that? Area. Area is what? So length into height. So length is half length is this one and the height is this one. So height is 9 into 10 to the power of 6 into length is 3000 into CG, center of gravity towards the support is L by 2. That is L is 3000 divided by 2 is 1500 that we have substituted. Plus, so I am doing the plus because both are negative sign, that's why I have taken the negative outside. So I'll take plus the area of the parabolic, half parabolic portion. So that is 2 by 3 into base into height. Height is 27 into 10 to the power of 6 that we have calculated into the CG from center of this to the center of gravity to the towards the support is 5 by 8 of the length. 5 by 8 of the length is 3000 that we have substituted. So then we got the answer as deflection is equals to minus 11.05. So that is the deflection due to pre-stress and the deflection due to dead load is over. So next we can calculate the maximum deflection due to the dead load and pre-stress. So due to the dead load is 1.48, due to the pre-stress is minus 11.05. So if I'll calculate, the total deflection is minus 9.57 I got, right? So that is the deflection I got. That is the first thing is over. The second thing is we need to find out the live load or the centrally concentrated force for this deflection. So deflection is upward. So minus 9.57 I got, that is the upward deflection. So that's why I'll take for the live load as the downward deflection of 9.57. So deflection due to the live load is equals to, so it's a point load. The formula is WL to the power of 3 divided by 48 into EC into IXX, right? So I can substitute the values and I can calculate the value of W. The W is only the unknown, right? So by doing this, I got the W value as 27.27 into 10 to the power of 3 newtons. So that we can convert into the kilonewton also, that is 27.27 kilonewton. Point load if you will apply here, so that will nullify and that will make the deflection, means the deflection should be it will become 0 at that part of time, right? So this completes the